Hey everybody, hope you guys had a nice weekend. It's good to see you guys again. This video is going to be for April 20th. Make sure again that you take out a new sheet of paper. You put the title is 420, and then we're going to make sure we just do some problems, and then got a little special surprise for you later on in this video. So you guys, today's going to be a recap before we move on to new material. So tomorrow you're going to get a video on new stuff. Today we're just going to review what we know about radicals. And remember, radicals is another term for square roots. Well, what we learned about square roots is whenever we have a number, the first thing we can do is we can type it in our calculator to see if it's what we call a perfect square root. Now, whenever I was looking at homework, I noticed that some of us are struggling a little bit on perfect square roots. So really pay attention and see if this makes sense and know how to use that key in your calculator. When you do the square root of 180, a decimal pops out on your calculator. That means it is not perfect and you have to do a factor tree for it. So you guys, here is the factor tree for 180. There's a lot of things that multiply for 180, but what I do is figure out the smallest number that fits into it. So I divide it by 2, and I know it's then 2 times 90, because that worked out. 2 is prime. 90. I divide by 2. It works out, and it's 2 times 45. 2 is prime. 45 I want to try to break up, but when I divide it by 2, I get a decimal, so 2 doesn't fit into it. But then I take 45, divide by 3, and it does fit into it. So it's 3 times 15. 3 is prime. Now hopefully when you get to 15, you don't have to use your calculator anymore. You know that it's the smallest number 3 times the smallest number 5 would work, and 3 is prime and 5 is prime. So whether you put 2 times 2 times 3 times 3 times 5 underneath that square root again, or you could just look at this factor tree. If you like to do it my way, then it's all swoop nice from smallest to biggest prime number. I could look for pairs to pull out. A pair of 2's gets to come outside the radical. A pair of 3's gets to come outside the radical, and then a 5 is trapped underneath that radical. Now, whenever we do variables, remember, you could write down all of your letters if you wanted to, but there is a quicker way. You're just looking for groups of 2, so you could just divide the exponents by 2. But if you really had to, you could write down x times x. But then you'll see that a pair of x's gets to come outside. Then you would have to write down 11 y's. Now, I find that to be a waste of time, but we could. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 y's. But if you took 11 divided by 2, you would have got 5 remainder 1. Well, let's see what 5 remainder 1 means. Pair of y's, y outside. Pair of y's, y outside. Pair of y's, y outside. Pair of y's, y outside, and a pair of y's, a y outside. The 5 represents 5 y's that get to come out, and the remainder represents what is trapped. All right, so you guys, we are ready to write our answer. On the outside, look at all these arrows. On the outside, we have a 2 times a 3 makes 6. That comes out as a single x. Single y, single y, single, single, single makes up 5 single y's out there, or y to the 5th. You put your square root symbol and you look for trapped pieces. Now it can be very kind of confusing, so make sure you're very organized in your work. But this 5 was trapped, this y was trapped. So I got 5y, and the trapped part's actually called your radicand, the piece underneath the square root. But that is how we reduce radicals. Now we also learned how to add or subtract radicals, but we had to remember, they have to be considered like terms. These are, so since they're both rad 3's, we simply add or subtract the numbers in front and leave rad 3. So you guys, we would have 8 minus 10 is negative 2. My marker is going a little dead here. Square root 3. And then we are done. So that is the basic concept of add or subtract radicals, but now we do want to see, well, what happens in a harder problem. Number 3 is going to be very important. Number 3 in our notes today is a type of problem that I noticed on the homeworks. Now remember, it's really hard for me to check every single homework problem, but as I'm looking at your Google Docs and the pictures you send me, I do scan it, and then I kind of make mental notes on what kids are struggling with, what they are doing well at. And number 3 is a problem that this type of problem is pretty hard for people. So make sure you really look at this one and see what you're going to need help with. Okay. Well, the reason why this one is a little bit more challenging is there's perfect square roots, and I think a lot of us get lost in that. We think we always are going to have a radical left over. That's not the case. Perfect square roots, there's no more radical. So you always want to test in your calculator whether they're perfect or not. So when you type in the square root of 2, it's a decimal. Now you would try to break that down, but it's a prime number. So nothing really happens to 9 rad 2. It stays 9 rad 2. There's a plus sign. And here is where a lot of us were struggling. Square root of 49 is perfect. It's no longer a radical, so there shouldn't be a radical symbol at all. When you do the square root of 49 in your calculator or in your brain, 7 is the final answer, and that's it, 7, no radical. So you guys, this comes down as a whole number 7, and it's okay. Then there is a minus sign, and this one is 8 rad 2. Again, rad 2 is a decimal in calculator, and it's prime, so we would keep that. But then there's a plus sign, and the square root of 4 is perfect. Now this one's going to be a little bit harder though. The square root of 4 is no longer a radical, but you should know what number it becomes. The square root of 4 becomes 2 is correct, but there was a 3 there also. So I kind of have a little intermediate step here. I have the number 3, touching means times in math, and that answer is 2. 3 times 2 makes a total of 6. So this one can be pretty challenging, but remember, we always try to reduce our radicals. And these radicals don't have to match up right away. Remember, this could be something that reduces to a factor tree, bring out a number. So you can watch the videos that we've already done. We've seen examples like these, but I try to make it a little bit easier on the radical part, not the perfect radical part. This is where we really struggled last week. And now we look for like terms. I can do this color coding. This one is a rad 2. This one is a rad 2. This one is a regular number. This one is a regular number. Now, as long as you put the blue pieces together and the red pieces together, you're correct. But math people would prefer to have the regular numbers first. So you guys, I'm actually going to take my red pieces, combine like terms. Positive 7 plus 6 makes 13. And then I'm going to take my blue pieces and put them together. And 9 rad 2 minus 8 rad 2. Well, 9 minus 8 is 1. You don't need to show the 1, but it's positive, so you do need the plus sign. And then 1 rad 2. If you put a 1 in front of the rad 2, you're not wrong. Math people just usually leave that blank. And that is your final answer. So again, struggled with perfect square roots a little bit, so just watch out for them. All right, last example of the day. Not only did we add and subtract radicals, we also learned how to multiply radicals last week. So in number 4, 3 square root of 6 times 9 square root of 30. Well, the little rule that we had was outside times outside stays outside, inside times inside stays inside. So I'm going to take the 3 times the 9, and that is outside the radical. I'm actually going to get the answer for that, is 27. Then I put a square root. Now I can multiply the inside times inside and put 180 here, but it makes my life harder. So I usually keep it as a times problem. 6 times 30. See? Inside times inside stays inside, and I do factor trees for that, for each individual piece under there. 6 is composite, so it's 2 times 3, prime, prime. 30 is composite, it's 2 prime times 15. 15 is composite, 3 times 5, prime, prime. So I only look at the prime numbers. So I'm no longer looking at 6. I'm no longer looking at 30 or 15. Once you use a factor tree, any of your composite numbers, you don't look at. You only look at the primes, what they break up to be. And the pairs are a little harder to see here, but there is a pair of 2s, there is a pair of 3s, and a trapped 5. So you guys, whether you rewrite them nice, you don't have to do this step, but it sometimes is nicer and easier for kids to make sure that you put all the numbers in order from smallest to biggest. So 2 times 2 times 3 times 3 times 5. So I used all my prime numbers up there. Now I can say a pair of 2's come out and a pair of 3's come out. So what I have on the outside is 27 times 2 times 3 square root 5. Now here is where you might want to use a calculator for sure, right? 27 times 2 is 54. 54 times 3 is 162 on the outside. Square root of 5 is my final answer. All right, you guys, again, I want to tell you thank you so much for the people that are doing exactly what they're supposed to do. This is going to pay off in the long run. Not only is it going to boost your grade in the class for participation, but it's going to give you the necessary skills to where you can be successful in geometry. All right, so, and then again, in Algebra II, this is all a building process, high school, especially in high school math. Everything builds off of each other, so you guys have to have these skills to be successful at the next level. So thank you again. It's going to benefit you, but I just want to tell you how proud I am of you guys for staying focused and keeping on task during this hard time. I know it's easily to get distracted or unmotivated, so for the people that are doing this, you're doing an awesome job. And here is your homework. Oh, it's your boy, Mr. Pete. Your homework is right there. You guys have a great day. Enjoy Monday.